How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And today we're going to be talking about theoretical probability of compound events. Before we start, I'd like to invite you to go ahead and subscribe to this channel. If you haven't seen my other channel, MTV Alex, I'll leave a link right there. Make sure you subscribe to that. And if you want to support this channel, link down in the description. So let's go ahead and get started. Now, theoretical probability of compound events. Just like before, when we talk about theoretical probability of single events, this is just going to be the continuation to that. Single event meant only one. Compound is going to be more than one. Now, if you haven't seen the single events, I can leave a link right here. And now let's go ahead and get started. It says, compound probability is the likelihood of two or more events occurring. So you're gonna be asking yourself, what are the possibilities of this happen and then this happen also? Okay, so like let's think about what are the chances of today raining and also having a hurricane. Okay, so those are the two things that kind of something like that. Okay, so it says to identify the samples. First of all, you have to identify the sample space, use a list, a tree diagram, or a table in order, if the order does not matter, cross out repeated combinations that differ only by order. 2, count the number of outcomes in the desired event. Just like before, remember we have the formula probability is going to be the number of things, whatever you want to happen, divided by everything that can possibly happen. Which is going to be the total number of outcomes, okay? So basically, to find the probability of one thing is going to be whatever you want to happen or whatever they're asking you is going to go on top, the part, and the total is going to be everything that can happen, okay? It's just part over total. Now it says, number 3, divide by the total number of possible outcomes. That's what I just have on the formula. Okay, so for instance, over here, we have a student that has a spinner and rolls a number cube. Remember, number cube is a dice, have 6 sides, usually numbers 1 through 6, okay? Not necessarily all the time, but usually they're just numbers 1 through 6. Okay, what is the probability, and this is the question, that she will randomly spin a 1 and roll a number less than 4, okay? Less than 4. So remember, when we have the cube, you have the cards, or the faces. These are the 6 faces. You have numbers 1, 2, 3, 4, 5, 6. Okay, these belong to the cube right here. Now, they're asking for a number less than 4. Is it included the 4? Keywords from inequalities, right? So no, it's not including the 4. So you're actually only looking for the numbers 1, 2, and 3. Anything less than 4. In this case, they're the numbers 1, 2, 3. And it says, enroll and spin a number 1. Okay? So we're looking for these possible scenarios. Either getting a 1 or rolling a number less than 4. So she created a table, and this over here on the top is going to be the dice, and the side is going to be the spinner, right? Because there's only 3 possibilities for the spinner and 6 possibilities for the dice. So it says that if I roll the first roll and the first spin, I can either get a 1, 2, and 3, and then I can get those combinations 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Or I can get the second combination. If you roll this one, for example, the 2, you can get the 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, for example. Or if you pick this one, or if you spin that one at the beginning, you can get the combinations 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, so forth, so on. Those are the combinations listed on the table. However, those are everything, all the total combinations. Now, to find the whatever you want to happen. So it says over here, number 1, identify the sample space. We did that with the table or with the images. Count the number of the desired outcomes. So for the first one, I have how many things that can happen? Count the number of the desired outcomes. I have 3 desired outcomes. And then divide it by the total number of possibility. I have 18. So the total number of possibilities is going to be everything. The total number of possibilities is going to be all the combinations. Now the only ones that matches what I want, remember, I'm looking for a 1 and I'm looking for this right here, that combination. 1 1, 1 2 and 1 3. And those combinations are going to be right here. So that's the 3. And the 18 is all the possible scenarios. Now, for the probability of getting a 1 and less than 4 is going to be 3 out of 18. 3 out of the 18 on the total boxes. But when you simplify that, the final answer is 1/6. So basically, you just divide by 3. Now, there's a faster way to do this without doing the tables and all that. Okay, there's a faster way, and I'm going to show it to you right now. So, let's do green. If I look at the spinner, we're going to find the single probability for the spinner. They're asking for the 1, right? They're asking, what is the probability of getting a 1 on the spinner? Remember, it's part over total. How many 1s on the spinner? Remember? We have, wait. You have 1, 2, 3. How many 1s? You have 1. Out of how many? 3. Right? That's part over total. 1 over 3. Now, what is the possibility of getting a number less than 4 on the dice? Well, for those, I have 3 of them. 3 out of 6, right? So you gotta put it like this, 3 out of 6. Now, to find the compound probability, the faster way, all you gotta do is multiply these two. All you gotta do is again, 1/3 for the spinner, because you only have a 1 out of the 3, and then 3 out of 6 for the number cube, and all you have to do is multiply those two numbers. When you multiply that, 3 times 1 is 3, 3 times 6 is 18, which is the same number that we got over here, and when you simplify that, divide both of them by 3, you get 1/6, which is my answer. That's the faster way. You don't need to do tables unless they ask you to do the tables. Okay? Now let's look at this sample right here. It says at a party, sandwiches are served on 5 types of bread. Okay? Think about Subway, right? So they have different types of bread, different types of meat, they have the veggies and all that kind of stuff. It says they have 5 breads. So they have multigrain, they have pita, they have rye, they have sourdough, and they also have whole wheat. Okay? So they have 5 different ones. And Sam and Ellen each randomly grab a sandwich. What is the probability that Ellen gets a sandwich on pita or rye, and Sam gets a sandwich on multigrain or sourdough? Sam is gonna be multigrain or sourdough for Sam, and for Ellen, she wants to get a pita or rye. Okay, so Ellen gets a pita or rye, and Sam gets a multigrain or sourdough. Let's follow the instructions. It says, number 1, the table shows the sample space. Draw an X in each cell. Ellen gets a sandwich on pita or rye. So Ellen, an X. So we're gonna get pita. We're gonna put a X. All of this, right? And rye. Pita or rye. And then draw a circle in each cell in which Sam gets a sandwich on multigrain or sourdough. So we're gonna put a circle on this. Okay, so now we're gonna count the number of possibilities that have both an oval and an X. So we have this one, this one, this one, and this one. So how many possibilities is that? That's just 4, right? 4 possible combinations. Now, it says divide the number you counted in step 4 by the total number of possibilities. The total number of possibilities, since we have 5 types of bread and 2 people, each person is gonna have the same combination, 5 times 5, right? We have 5 going this way, 5 going this way, so 5 times 5 is 25. So this is going to be 4 out of 25. Now, if we can simplify that, we do that. In this case, we can't. But yes, you can convert it to a decimal and to a percent. So if you multiply this, if you have the fraction 425, you can easily convert that into a hundreds by multiplying times 4. So you get 16 hundredths, which is going to be 0.16 or 16%. So the answer choices they could give you is this, this, or this. Now this is the probability that Ellen gets a pita or a rice sandwich and the Sams get a multigrain or sourdough. So that's it for compound probability. We're gonna be talking about a little bit more about this in future videos, so stay tuned for that. Make sure you turn the notifications bell on so that you don't miss those videos. They're coming up soon, shortly after this one. That is it for this one, guys. If there's any questions, please write them down in the comments below. I'll be glad and happy to help you. Other than that, that is it for today, guys, and I'll see you on the next one. Goodbye.